you that some of the brightest minds can be found right here in our area. The Jesuit High School Robotics team recently won an international competition in Houston, Texas.
Yeah, it's very cool. This year's theme related to the oil spill in the Gulf of Mexico. Joe Griffin joins us live to show us what they built and how it works. This is very impressive. Good morning to you.
Morning.
So you got your team. We're doing great. So you got your team behind you. You guys are up early to join us this morning. So thank you for that. Show us the ROV, and what are you guys calling it?
We're calling the ROV 4Cs.
4Cs.
And the name actually comes from Greek god who rules over the dangers of the deep. This is the ROV here itself.
Oh wow. So you guys all built this. So how does it work?
Well, there's 4 missions that we had to do. It has to go down to 40 feet. Okay. So we used an O-ring seal that gets tighter as you go deeper and deeper. So the seal gets better as you go deeper. We've got 4 thrusters here and here, and then 2 vertical thrusters up on top. And that allows us to move around any way we need to. We've got a couple of guys on the team who coded the ROV, so it uses what's called vector thrust. And that allows us to move sideways, forward. We can turn, and we can do it all at the same time. So it's really maneuverable.
Are the thrusters hydraulic or are they propeller driven?
They're propeller driven, actually. I don't know if you can see it, but right now they're idling, just because that's sort of the part of the code that where you're sitting, it idles a little, just because it always keeps the thrusters running.
You can actually put it in the water, right? The ROV unit that you guys built?
Yeah.
Okay.
Yeah, so we've got the ROV on deck here. So guys, let's put the ROV in the water here.
Okay. So this is what your team built. You took this to Houston, took top honors among 26 teams around the world. Oh, look at this. We've got the underwater cam so we can actually see it.
Exactly.
And how it works.
This is pretty cool.
This is very cool. So, is there someone in the water as well? Oh,
hey.
Nice.
Yeah, we've got a diver in the water right now. I think we've also got our video feed running to you.
Yeah, that's great.
I think it'll be up in a second here.
Oh.
Yeah, so I think you can see it.
Yeah.
So now we're looking at POV from the actual robot. Is that right?
Yeah.
Okay.
Yeah. This is the video feed that our pilots look at while they're doing the mission itself.
Oh, okay.
So right now we're doing one of the missions. This is one of the props that we practice on, is what you should be seeing.
Okay. Yes.
And we should point out that the pilots are topside. They're not in the water. They're topside just watching video monitors doing this a la remote control.
Yeah, the pilots aren't allowed to look into the water. They actually, during the competition, have to sit at a table facing away from the water itself.
Oh, wow. So you had a couple of different missions. Tell us which one you're doing right now.
All right, so one of the missions that we had to do is we had to go down to a riser pipe, and it was supposed to look exactly like the BP oil spill. We had to cut the riser pipe that the oil was flowing out of, or leaking out of, and then we have to cap the wellhead. So right now we're trying to hook the riser pipe to get it out of the way. And then next we're going to cap the wellhead, and that's what we're going to show you right now.
And this is a mission that you guys actually were the fastest among the other teams, right?
Yeah, we finished this mission in about just over 7 minutes. I think it was 7 minutes and 45 seconds or somewhere around there. But we were the fastest. The team that was closest to us next, they got second place, was Purdue, actually. They finished it in about 11 minutes, I believe it was.
Losers.
We get the mission in December, and we start working on it from there. We start brainstorming and, buy materials and start making the frame and all the accessories right away. So we've been working since about December till this competition here.
I've got to say, I know you're doing this, and it's on a smaller scale than the actual pipe, but just the fact that you're able to do this and maneuver this is breathtaking and brilliant. This is really amazing.
Very cool.
Yeah, so one of the things that we were concerned about with the design was actually just to show that it would be viable at a higher size, was to show that we could scale it up. We used a couple of metal grippers here to grab onto the lip on the wellhead here, and then we used this black seal that runs up here, and that just sort of lays up against the wellhead. And so there's a check valve up here that is pushed down so it lets water flow through, so the pressure doesn't build up while we're trying to put it in place. And then as the ROV comes up and off of here, the check valve gets released so that, creates a seal up there. And then this seal, it actually acts a bit like the O-ring seals that I was talking about earlier, where since the pressure's getting tighter and tighter up in here, this seal actually lays flatter and flatter against the side of the wellhead, so the seal gets tighter and tighter.
Right,
as
being
the
compressed
pressure
by
gets
the water
stronger.
depth. That's really amazing. Congratulations.
Yeah.
We can see why you guys took the honors, first place, and